All right, you guys, my favorite stuff ever we're going to get to today. And you might be like, Eberly, the special right triangles were pretty awesome and you loved those problems. I know I did. I really did. But this next section, we get into trigonometry. And this is the study of triangles. That's all it is. Studying triangles, people. And you can take a whole year's worth of class on just trigonometry. And I don't think you guys have done anything with trig because you went from 6th grade math, I think, this is what you did, and then you skipped to algebra. So you might not have been introduced to trigonometry at all. If you had been, you would remember these types of words because these are certain ratios that we're going to use today, that you're going to be introduced to today. One of them being the sine ratio, one of them being the cosine ratio, and the other being the tangent ratio. There are more ratios, but these are the three that we're going to look at today and deal with in geometry this year. When you get into pre-calc, you'll go into more ratios. So these are going to help us, these ratios, determine side lengths and angle measures in right triangles. And you might be like, well, I don't need them because I have the Pythagorean theorem. And we have from yesterday or from last week the special right triangle stuff. But the thing is, here's the situation. What if I get a problem that I have a right triangle and it tells me this is 54 degrees, this is 17, and it says to solve for the missing sides. Tell me what the other side lengths are with this given information. So when I look at this, I can't use the Pythagorean theorem because I'm only given one side length. I'd have to be given at least two. I could not use the properties within the special right triangles because this 54 degrees tells me this is not a special right triangle because it's not a 45-45-90 and it's not a 30-60-90. So how the heck do I do this? Well, I have to use the sine, cosine, or tangent ratios. So these trigonometric ratios you'll need to know off the top of your head. And this saying that maybe you've heard before, so, and it needs to be spelled correctly, ka, toa, is going to help you remember these ratios. So you have the sine, so this stands for the sine function, okay? And instead of writing out the whole thing, sine, in mathematics, we actually abbreviate it, but when we abbreviate it, we do not call it sin. We still say sine of an angle, of a certain angle that we're looking at, equals the opposite side over the hypotenuse side. All right? The cosine of a certain angle that we happen to be looking at is the ratio of the adjacent side over the hypotenuse side. So as you can see right now, both the sine and the cosine have hypotenuse love. Okay, they both love the hypotenuse because they're in the ratios. And then the tangent does not have any hypotenuse love. The tangent of an angle that we're looking at is the ratio of the opposite side over the adjacent side. So when we're making use of these particular ratios, get your calculators ready because you're going to be using your calculator. The other way to figure this out, you'll learn in pre-calculus, and we could also make use of a table of values where you can look them up. But the calculator is going to be the quickest way to figure this out. So let's just start off really simple. Okay, so let's say we have a triangle and we have triangle TGR. And we know all the side lengths. Okay, let's just say we're practicing with the ratios. And I ask you, what's the sine of angle T? Well, the sine of angle T would be equivalent to the ratio of opposite over hypotenuse. So I'd look at the angle T, which is right here. This is that angle. And I need to go to the opposite side of that angle. which is 8. I'm going to write out 8 over the hypotenuse. And the hypotenuse is the same no matter what, 17. So the sine of angle T is equivalent to this ratio, 8 over 17. Let's practice with the cosine. The cosine of angle T. So now I'm going to erase what I did here. The cosine of angle T is now not 8 over 17, but it still has 17 because it has that hypotenuse love in the denominator. But cosine is adjacent over hypotenuse. And what is adjacent to angle T? Well, it's either 17 or 15, and 17 is already the hypotenuse. So 15 would be the numerator. And then the last one, tangent of T is equal to, and tangent is TOA, opposite over adjacent. So if I go to the opposite side of angle T, that is 8 over the adjacent side, which is 15. You might say, what are we doing? We're preparing to solve for when we have triangles that are like this. Okay, we're prepping for this. So I want you to go ahead and try got it problem number 1. And I'm going to go through it right now. So go ahead and pause the video, try it out, get your ratios. Okay, so here is the got it answers for number 1. We have the sine of G is 15 over 17. Cosine of G, the ratio is 8 over 17, both with the hypotenuse love of 17. And then we have tangent of G at 15 over 8. Now, why the ratios changed is because our angle of reference changed. So you have to change the way you're looking at the problem. Okay? All right, so now I'm going to go ahead and try the problem with you that I had put down earlier. Okay? So now we have the issue of we can't use the Pythagorean theorem, we can't use the 45, 45, 90, or the 30, 60, 90. So now we have to look at what we're given and say, okay, we're given the 54 degrees, and we're given the hypotenuse. When I think about my trig ratios, sine, cosine, and tangent, which one has hypotenuse love? Sine and cosine. Tangent does not, so I'm going to throw that one out. Now, between sine and cosine, which one am I going to use? Well, I'm given the 54 degrees to reference. So if I say sine, I'm going to go sine of 54 degrees, because that's the angle that I'm referencing, that's what I'm looking at, equals the ratio of, and sine is so, opposite. So my opposite side is not given. So I'm going to put x, so we can solve for this side, over the hypotenuse of 17. And now I have an equation that I can solve, because I have one unknown. So to solve for this, I'm going to have to make use of my calculator. I'm going to have to punch in sine of 54 degrees. So I'm going to go to my calculator. I'm going to make sure my calculator is in degree mode. And I'm going to do the sine of 54 degrees. I have to figure out how to do this on this calculator. 54 sine. I want to make sure it's in the right mode. I don't know if this one is. I don't know how to get to the mode on this calculator. Degrees. Okay, there. It's in degrees. So I'm going to go sine of, what was that, 54 degrees. And there's my number. It's gross. Okay, 0.80901, blah, 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 blah. So you know what? I'm not going to rewrite that out. But I will just for you, 0.809, blah, 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 blah. I'm going to keep it on my calculator because to get the x value, I'm going to have to get rid of the division by 17. So to do that, I'm going to do the inverse operation of dividing, which is multiplying. So use the multiplication property of equality and multiply by 17 on both sides. So that when I do that on the calculator, I'm going to have that number that I did not approximate, and I'm going to multiply it by 17. And I'm at my side length of 13.75, which if I round it to the 10th, would be 13.8. Okay? Whoa, that was amazing.